this video, we are going to discuss about properties of discrete time Fourier transform. So first property is Parsel's theorem. So it is also called as energy theorem or Rayleigh's theorem. So what it means is the energy of the signal here can be expressed as frequency components average energy. So let us discuss the theorem first. The Fourier transform of so the energy that is equal to minus infinity to infinity x of n modulus of x of n the whole square, that is equal to 1 divided by 2 pi summation minus pi to pi. So since it is 2 pi, it ranges from 5 to pi modulus of x of e power j omega the whole square d omega. So I'm going to prove this one. This is what I need to prove. Okay, so the proof is so let me take this equation. Okay, summation n is equal to minus infinity to infinity summation x of n the whole square. So this I can write it as, so summation n is equal to minus infinity to infinity x of n the whole square. That is, I can write it as summation n is equal to minus infinity to infinity x of n into x of complex conjugate of m. Okay, this modulus I can write it as. Okay, so what is x of n is equal to 1 divided by x of e power j omega n d omega. So this is x of n. Okay, so x of x complex conjugate of n, that is equal to 1 divided by 2 pi integration of minus pi to pi x complex conjugate of e power j omega e power, this is fast to be plus, right? So here it is minus omega n d omega. Okay, so we know that the summation x of n, this is what we need to this is my left hand side value, that is equal to it can be written as summation n is equal to minus infinity to infinity. The x of n is written as can be written as 1 x of n into x complex conjugate of n, right? So here this I can write it as summation n is equal to minus to infinity x of n. I am keeping it as same. Instead of x x complex conjugate of n, I am going to substitute to the above equation. Okay, and from the above equation, okay, I am going to take 1 divided by 2 pi minus pi to pi outside. Okay, so you will get summation n is equal to minus infinity to infinity x of n, right? So e power minus j omega n, right, into x star of e power j omega d omega, right? So this I can write it as 1 divided by 2 pi minus pi to pi. This is nothing but x of e power j omega, right? X of e power j omega into x star of e power j omega d omega. So I can write this one as 1 divided by 2 pi minus pi to pi modulus of x of e power j omega the whole square d omega. So hence let us put differentiation in frequency. So to prove is Fourier discrete time Fourier transform of n of x of n, that is equal to j into d by d omega x of e power j omega. Okay. So we know the formula for Fourier transform, right? But before this one, what is x of e power j omega? X of e power j omega is equal to summation n is equal to minus infinity to infinity x of n e power minus j omega n is the formula for a discrete time Fourier transform. So if I differentiate this one, okay, with respect to d omega, so I will get summation n is equal to minus infinity to infinity x of n. So here only I am having the omega term. So if I differentiate with respect to omega, I will get minus j here, right? So you will get minus j summation n is equal to minus infinity to infinity x of n, right? E power minus j omega n into n, right? So if I multiply both side on j, okay, if I multiply both side on j, so I will get so if j into j square is minus 1, so this 2 get cancelled out, so I will get n is equal to minus equal to infinity n x of n e power minus j omega n. So this is nothing but Fourier transform of discrete time Fourier transform of n into x of n, right? So that is a proof. So the next one is time shifting property. So what is time shifting property? To prove is Fourier transform of x of n minus k, that is equal to e power minus j omega k, right? X of e power j omega. This is what I need to get. So the proof is Fourier transform of x of n minus k, right? X of n minus k is equal to summation x of n minus k e power minus j omega n, where n ranges from minus infinity to infinity. So I am going to substitute p. So if I substitute u is equal to n minus k, and therefore n is equal to u plus k, right? So if I substitute n is equal to minus infinity, u is equal to minus infinity, right, in this above equation. If I substitute n is equal to infinity, u is equal to infinity. So I can write this one as u is equal to minus infinity to infinity, right? So even if you change, you will get the same answer only. So x of u e power minus j omega, instead of n you have to substitute u plus k. Okay. So this I can write it as e power minus j omega k, e power minus j omega k, summation u is equal to minus infinity to infinity x of u e power minus j omega u. So even if you substitute u is equal to infinity, you have to write like this only. So this is equal to e power minus j omega k x of e power j omega. Hence the proof. Okay. Frequency shifting property. So what is property is x of n e power minus j omega n omega naught n is equal to x of e power j omega minus omega naught. Okay. So the proof is f of x of n e power j omega naught n, that is equal to summation x of n e power j omega naught n e power minus j omega n, right? From n is equal to minus infinity to infinity. So this I can write it as summation n is equal to minus infinity to infinity x of n e power minus j omega j jn omega naught plus omega, right? So this I can write it as x of e power j this is omega naught, omega minus omega naught, right? Omega minus omega naught. So if I take minus inside, I will get e power minus j n omega plus e power j n omega naught. So you will get omega minus omega naught. So this is about your frequency shifting. Next one is time reversal. So Fourier transform of x of minus n, that is equal to x of e power j omega minus j omega. Okay. So the proof is f of x of minus n, that is equal to summation x of minus n e power minus j omega n, where n is equal to minus infinity to infinity. So I'm going to substitute u is equal to minus n. So if I substitute n is equal to minus infinity, u is equal to infinity, and n is equal to infinity, I'll get u is equal to minus infinity. So if I substitute, I'll get x of n u is equal to infinity to 2 is equal to infinity to minus infinity, right? X of u e power minus becomes j omega u, right? This I can change it, right? So this I can change it to u is equal to minus into infinity x of u e power j omega u. So this I can write it as x of e power minus j omega. So the next one is convolution theorem. Here we need to prove Fourier transform of x of n, x1 of n convolution x2 of n is equal to x1 of e power j omega into x2 of e power j omega. So the proof is Fourier transform of x1 of n convolution x2 of n, that is equal to summation n is equal to minus infinity to infinity x1 of n convolution x2 of n e power minus j omega n. So how to write the formula? N is equal to minus infinity to infinity. Formula for convolution, I can write x of summation of minus tau is equal to minus infinity to infinity x1 of tau h of n minus tau. So this is a formula for convolution, okay, into e power minus j omega n. So in this formula, if I substitute p is equal to n minus tau, okay, I can write n is equal to p plus tau. So if I substitute n is equal to minus infinity in the above equation, you will get p is equal to minus infinity. If I substitute n is equal to infinity in the above equation, p is also equal to infinity. So this I can write it as summation n is equal to summation tau is equal to minus infinity to infinity x1 of tau summation, instead of x2 of n minus infinity, I am going to substitute p, okay, e power minus j omega, instead of n I am going to substitute as p plus tau. So instead of n I am going to substitute p. So p is equal to minus infinity to infinity. So this I can write it as tau is equal to minus infinity to infinity x1 of tau e power minus j omega tau. from this one. Summation p is equal to minus into infinity x2 of p e power minus j omega p. Therefore, I can write this one as x1 of e power j omega into x2 of e power j omega. So, hence the proof. Okay, so the next property is so the next one is modulation theorem. So we need to prove Fourier transform of x of n cos omega naught n is equal to 1 divided by 2 x of e power j omega plus omega naught plus x of e power j omega minus omega naught. So the proof is Fourier transform of x of n cos of omega naught n, that is equal to summation n is equal to minus infinity to infinity x of n cos omega naught n e power minus j omega n. So instead of x of n, I am going to substitute x of n cos omega naught n. So summation n is equal to minus infinity to infinity x of n. This cos omega naught, I can write it as e power j omega naught n plus e power minus j omega naught n divided by 2. So this is the formula for cos omega naught n, e power minus j omega n. So in this I can take 1 by 2 common. Summation n is equal to minus to infinity x of n e power minus j n, I can take it common. I can write it as omega naught minus omega naught plus omega, right? Then again I can split this one as plus summation n is equal to minus infinity to infinity x of n e power minus j omega plus omega naught of n, right? So thus I can write it as x of e power minus omega minus omega naught, sorry, e power plus, right? Omega x of e power j omega minus omega naught plus this I can write it as x of e power j omega plus omega naught, right? So hence the proof. So both are same, right? So the next one is symmetry property. We have to prove x of e power j omega is equal to xr of e power j omega plus j into xi of e power j omega. So we know that the Fourier transform, the proof is Fourier transform of x of n, that is your x of e power j omega. Formula is summation n is equal to minus infinity to infinity x of n e power minus j omega n, right? This minus, so this is equal to summation n is equal to minus infinity to infinity x of n. The second write it as cos omega n minus j sin omega n. So this is equal to summation n is equal to minus infinity to infinity x of n cos omega n minus summation n is equal to minus infinity to infinity j sin omega n x of n. So that is equal to x r of, this is your real term, right? J omega plus j xy of e power j omega. So where xr of e power j omega, I can write it as summation n is equal to minus infinity to infinity x of n cos omega n. whereas xi of e power j omega, I can write it as xi of e power j omega, I can write it as minus of summation n is equal to minus infinity to infinity x of n sin omega n. Okay, so what is even symmetry? Okay, from this so this is called as even symmetry. Okay, so what is the formula for even symmetry is so even symmetry, what is even symmetry means xr of e power j omega is equal to xr of e power minus j omega. Okay, so what is xr of e power minus j omega? That is equal to summation n is equal to minus infinity to infinity x of n. So for minus omega you have to substitute here, right? Cos of minus omega n. So cos of minus omega is cos omega only. So that is equal to n minus infinity to infinity x of n cos omega n. So that is equal to xr of e power j omega. So this is about even symmetry, right? So similar way the odd symmetry, xi of e power minus j omega, that is equal to minus of xi of e power j omega. Okay, so what is xi of e power j omega? So here you have minus 1, right? So xi of e power j omega is equal to minus summation n is equal to minus infinity to infinity x of n sin omega n. So this is from the above equation, right? So if I substitute minus xi of e power minus j omega in the above formula, so I will get minus summation n is equal to minus infinity to infinity x of n sin of minus omega n. So sin of minus omega is minus sin omega. Okay, so you will get summation n is equal to minus infinity to infinity x of n sin omega n, which is nothing but minus of xi of e power j omega. So hence it is proved. So xi of e power minus j omega is equal to minus of x of I e power j omega.